Learn together, pass together, grow together. So, our today's topic is what is router? So, you hear the word router all the time, and I think that can actually make it harder to understand. It feels familiar, so your brain goes, yeah, yeah, your internet box, got it? Actually, no, not really. A router is not just the thing that gives me Wi Fi or that box connected to my ISP, Internet Service Protocol. Its real job is much better than that. And once you see it, a whole lot of network starts to click. Here's the thing, a switch. A switch helps devices talk inside the same network, but a router helps devices talk between different networks. That's the big idea. If Johnny's computer wants to talk to Mark on the same local network, the switch can handle that all day long. But if Johnny wants to reach the example.com website sitting on a totally different network, the switch is out of its league and the router steps in. And the difference matter way more than the most people realize. Networks are defined by their IP addresses range, but not just by devices they are plugged into. So, if one group of devices lives in the 10.1.1.x network and another lives in 23.227.38.x network, those are two separate neighborhoods, and Johnny can't shout across town and hope the switch figure it out. It needs a guide, a map, and a way out. That guide is router. So you might be have a question like, can't we just plug in all in a switch? You might be thinking, right? Okay, but couldn't I just connect the two switches together and call it a day? I mean, short of physically, yes, you can plug them together, but logically that doesn't solve the problem. You had just have a bigger switched environment and the devices would still be dealing with separate IP networks. That's the part I really want you to grab. The issue is not these devices are on different switches, the issue is these devices are on different IP networks, right? That's why the router matters. It understands on OSI layer 3, which is the layer where IP network addresses lie, and uses that information to move packet from one network to another network. So that's why I spent so much time walking through the packet flow. I wanted you to see that a switch and a router are not competing devices. They are doing different jobs. The switches handles local delivery and the router handles getting your network off your local network and onto another one. Now, the huge deal about the gateway. This is where the term default gateway finally stops sounding weird. Your default gateway is usually the router interface on your local network. In Johnny's case, that was 10.1.1.1. So, when Johnny wants to talk to something outside his own network, he doesn't try to find the remote server's MAC address directly. He already knows that won't work. He already knows that won't work. Instead, he sends the traffic to the router, saying in effect, hey, you know how you get there, you take it. That is huge. It means your computer is constantly making little decision like this. Is this destination local or is it somewhere else? If it's local, it uses ARP, Address Resolution Protocol, to discover the other device's MAC addresses and hand the frame to the switch. But if it's remote, it uses ARP to discover the router's MAC address because the router is the next stop. Same local process but different destination. And yes, that's one of those sneaky networking ideas that feels small until you realize it explains almost everything. Why do you need a gateway configured on your PC? Because without it, your device has no exit door. It can talk to the neighbors, but it can't leave the neighborhood. I have a tip. When a device can reach local machines but not the internet, one of the first thing I check is the default gateway, wrong gateway, missing gateway, or gateway that's down will break off network communication fast. You will look like a wizard for spotting it early, but really you are just understanding how routing actually works. Now let me put this all together, because this is where it gets wicked cool. Johnny builds a packet with the destination IP of the example server. That IP stays the same from end to end, but layer 2 frame, the part carrying the MAC addresses, changes as the traffic move across the network. First, it goes from Johnny's MAC address to router MAC address. Then the router rebuilds the frame and send it out using its own MAC address as a source and the example server MAC as the destination. This is such a big concept. The packet is the layer 3 information, the where this ultimately needs to go. The frame is the local delivery wrapper used on each segment of the network. So when the router receives a frame, it stripes off the old layer 2 information, looks at the layer 3 destination and checks its routing table and then build a new frame for the next network. Boom, that's routing. If you want me, I can read it again. So let's understand again that the frame is the local delivery wrapper on each segment of network. So when the router receives a frame which is working on layer 2, it stripes off the old layer 2 information which consists of MAC addresses. So it looks at the layer 3 destination which is working on IP addresses, checks its routing table and then it builds a new frame for the next network which is gonna be the destination network. So this is routing. You got my point. And if router doesn't know the remote device's MAC address yet, it has the same problem Johnny had earlier. It uses ARP on the local segment to learn it, so the process repeats like it's all the same process which each router has. Like when someone from the another network wants to talk to another network, they connect through the layer 3 through IP addresses, and then when then source IP reach at the another network, it starts talking or communicating on layer 2 like founding MAC addresses using ARP, which is address resolution protocol. So the process repeats just on the other side. Okay? The router is constantly making layer 3 decisions and then wrapping traffic in whatever layer 2 delivery information is needed for the next hop. Now the DNS comes. Hang on, cyber for the moment. We also touched on something that happens all the time but usually stays invisible, which is DNS. That stands for Domain Name System. And it's what translates a friendly name like example.com into an IP address. Router do not route based on names. Switches doesn't switch based on names. Names are for the human, but network needs numbers. So before Johnny can even request the website, he first has to ask the DNS server, hey, what IP address belongs to this name? Once he gets the answer back, then he can start the normal process of sending traffic to web servers. DNS lookup first, then routing, then delivery, and then response. Okay? And I hope you don't read through that and think, man, this is too much. This is not too much. It's layered. That's the beauty of networking. One step at a time, one job per device, one protocol solving one problem. Once you see the pattern, the internet stops feeling magical and start feeling understandable. The last piece, I wanted you to see the router's routing table. That's just a fancy way of saying the map inside the router. It contains the network the router knows about and where to send the traffic to reach them. In our simple lab, the router knew one network was directly connected to the another interface or one interface, and another network was directly connected on another interface. Easy. In the real world too, internet router can have massive routing tables with routes to insane number of networks. That's why routers are so powerful. They aren't just blindly forwarding traffic, they are making decisions based on the map of reachable destination. And that map can be tiny in a lab or absolutely enormous in the internet or on the internet. So, if you remember nothing else from this lesson, remember this one thing. Router connects network. Router connects one network to another network. It is the device your computer hands traffic to when the destination is outside the local network. The switch handles the local conversation and the router gets you to the another world.